Good morning. Welcome to another session of MCN201 Sustainable Engineering. In the last session we had seen EIA, and in this session we will see industrial ecology and industrial symbiosis. I am Dr. Unnikrishnan PC, Professor Electrical and Electronics Engineering Department, Rajagiri School of Engineering and Technology, Cochin. Before we proceed further, let us see a quote by Bhagat Singh. Bombs and pistols do not make a revolution. The sword of revolution is sharpened on the whetting stone of ideas. So today we are winding up module 3 with industrial ecology and industrial symbiosis. What is industrial ecology? Let us see what Frosch says: a system that would maximize the economical use of waste materials and of products at the ends of their lives as inputs to other processes and industries. Essentially mimics natural systems. Industrial ecology is a system approach based on engineering and ecological principles that integrates the production and consumption aspects of the design, production, use and termination of products and services in a manner that minimizes environmental impact while optimizing the utilization of resources, energy and capital. We can summarize the whole approach of industrial ecology as the goal is cradle to reincarnation, since if one is practicing industrial ecology correctly, there is no grave. Let us see what are the principles of industrial ecology. The first one is create industrial ecosystem, close the loop, view waste as a resource, create partnership with other industries to trade byproduct which can be used as input to others. Secondly, balance industrial inputs and outputs to natural levels, manage the environment industrial interface, increase ecosystem behavior, recovery time and capacity, increase knowledge and how industries can interact with natural ecosystems and the limitations. Thirdly, dematerialization of industrial output, use less virgin materials and energy, becoming more resource efficient, reuse materials or substitute more environmentally friendly materials, and in general do more with less. And fourth, improve the efficiency of industrial processes. This might need redesign of products, processes and equipments. Finally, energy use. Incorporate energy supply within the industry ecology. Use alternative source of energy like renewable energy that have less or no impact upon the environment. And finally, align policies with the industrial ecology concept. What are the benefits of industrial ecology? Cost savings, improved environmental protection, income generation by selling waste or byproducts, enhanced corporate image, improved relation with other industries and organizations. One such example is an eco-industrial park in Pevens, Massachusetts. We should leave the next generation a stock of quality of life, assets no less than those we have inherited. Pevens Enterprise Commission. Now let us move on to industrial symbiosis. Industrial symbiosis engages traditionally separate industries in a collective approach to competitive advantage involving physical exchange of material, energy, water and or byproducts. The part of industrial ecology known as industrial symbiosis engages traditionally separate entities in a collective approach to competitive advantage involving physical exchange of material, energy, water and byproducts. The key to industrial symbiosis are collaboration and the synergistic possibilities offered by geographic proximity. One such example is the Kalundborg Eco-Industrial Park in Denmark, a community of manufacturing and service businesses seeking enhanced environmental and resource issues including energy, water, materials, information and natural habitat. The model of industrial symbiosis was first fully realized in the Eco-Industrial Park at Kalundborg, Denmark. The primary partners in Kalundborg, an oil refinery, power station, gypsum board facility, pharmaceutical plant and the city of Kalundborg literally share groundwater, surface water and wastewater, steam and electricity, and also exchange a variety of residues that become feedstocks in other processes. The waste exchange alone amount to some 2.9 million tons of material per year. Water consumption has been reduced by a collective 25% and 5,000 homes receive district heat. So you can see the flow of signals or flow of materials physically in this block diagram. So a large a power station with large number of ancillary units getting byproducts or using the byproducts, and finally even the fly ash is converted into cement and then it is used for making roads. We will see a video now about Kalundborg in Eco-Industrial Park.
The world has to learn new ways of working together in order to solve the challenges we face in the 21st century. Challenges like water consumption, waste management, and the use of materials. If we can come up with new, intelligent ways of cooperating, new opportunities can be created that further economic growth, reduce our consumption of natural resources, and help to save the environment. The enterprises and authorities of Kalundborg, a city right in the heart of Denmark, are at the forefront of conceiving clever, cooperative solutions for these problems. Centers of some of Denmark's largest industries are situated in Kalundborg. Among others, the world's largest producer of insulin, the world's biggest enzyme producer, the largest water treatment plant in Northern Europe, and the world's first second-generation bioethanol demonstration facility, a project affiliated with the Dong Energy Power Plant in Kalundborg. The enterprises of Kalundborg have come together in collaboration aimed at organizing in order to utilize each other's waste products in a rotating local cycle. By creating a closed cycle of waste products between enterprise and authorities, a unique system has been created. Here, residue and byproducts flow in a minutely orchestrated system of production, where the byproduct of one company is the raw material of another company. Through this cooperation, the enterprises achieve an economic advantage, since all agreements in the symbiosis are based on sound business as well as environmental principles. Through millions of years of evolution, nature has created similar systems. In nature, there is no such thing as garbage. All output becomes input in a different part of the natural ecosystem. In this way, a falling leaf becomes part of the soil. The same principle is applied in the Kalundborg symbiosis. If other local communities are willing to learn from the experiences of the Kalundborg symbiosis and start their own industrial symbiosis along similar lines, we have the opportunity to create a healthier and better world, both environmentally and economically. The people at Kalundborg would be delighted to share their knowledge and invite anyone interested to contact them. The Kalundborg symbiosis is a good example of a new type of cooperation that can help build a richer, more sustainable and more harmonious world.
I have one more video about industrial symbiosis, growing tomatoes from an ethanol plant's waste heat and carbon dioxide. We may not see it completely due to time constraints. You can watch it from the YouTube.
This week we head off to Chatham, Ontario to see industrial symbiosis in action. This is the amazing story of an ethanol gas plant that produces animal oil for biodiesel fuel, fizz for pop, and heat and CO2 for a greenhouse that grows tomatoes. This is a case where one man's trash is indeed another man's treasure. Greenfield Ethanol has created an entire ecosystem around its plant where almost nothing goes to waste. Angelo Ligori is the plant manager.
So here an ethanol's waste heat is used in agriculture to produce tomatoes. So I wish all of you go to YouTube and see this video. These are some of the references and journals, publications. A lot of internet resources are also available. If you wish to contact me, you are free to contact me over phone or by email. And with that, I am Dr. Unnikrishnan, PC, signing off. Thank you very much.